All right, here we're continuing our algebra review, and this is section 2. And in this section, we're really going to be looking back at some geometry things that we're really going to need. So here are our learning targets for today. First, we're going to be using the Pythagorean theorem and its converse. Then we're going to go through some just general geometry formulas that we're going to be using, and then looking at congruent and similar triangles. So the first thing is the Pythagorean theorem and the converse. So remember, with the Pythagorean theorem, we're always dealing with a right triangle, which is 90 degrees, and our two legs we're going to call A and B. Those are the two sides touching the right triangle, the right angle, and then the hypotenuse, which is C, is across from that right angle. Okay, so hopefully you know this. This is the Pythagorean theorem that I have a squared plus b squared equals c squared. So I square the lengths of both legs and add them together, and that equals the hypotenuse squared. Okay, so now we're going to look at this example. In a right triangle, one leg has length 4 and the other has length 3. What is the length of the hypotenuse? So I always want to start by kind of drawing a just general triangle, right? And here's going to be side length 3 and 4. So that tells me that here's what I'm looking at, right? So I know I'm going to have 3 squared plus 4 squared equals c squared. 3 times 3 is 9. 4 times 4 is 16. Equals c squared. So then I add those, so 25 equals c squared. To undo this exponent, I always take the square root. And when I take the square root of something, it's plus or minus. But in this case, just like we talked the domain in the last section, I don't care about the negative one, because I can never have a negative side length of a triangle. So I know that that side length is going to be a positive 5 equals c. And that's just what is shown here in this solution to that. Okay, so now here's the converse. In a triangle, if the square of the length of one side equals the sum of the squares of the lengths of the other two sides, the triangle is a right triangle. And the 90 degree is always going to be opposite the longest side. So let's look at this example. So I want to verify that this triangle is a right triangle. So I want to show that if I have side lengths 5, 12, and 13, it's a right triangle. And identify the hypotenuse. Well, I know if it's going to be a right triangle, then the hypotenuse will be the longest side. So let's go ahead and look at this. We're going to first go ahead and set up all of the squares of all of the side lengths that we're given. So I've got my 5 squared, 12 squared, and 13 squared. So I look at these, the two smaller ones, and I add them together, and I see that that does, in fact, equal this third one. So that tells me that it is a right triangle. And because it's a right triangle, I know that this longest side will be the hypotenuse. So then I can draw my figure exactly as it should look. So now we're going to apply this Pythagorean theorem. So the tallest building in the world is in Dubai, which is in the United Arab Emirates, at 2,717 feet and 163 floors. So the observation deck is 1,483 feet above ground level. How far can a person standing on the observation deck see with the aid of a telescope? So we're using the Earth's radius, which is 3,960 miles, to help us kind of figure this out. So the first thing we always want to do is draw a picture. And here's kind of our picture. We're going to use the radius of the Earth, because I know this distance now, and I know this entire distance, so I'm finding the third side of a right triangle. So let's look at our solution. Okay. So this is exactly what I was just doing. I drew my two radii, one through the building and one through the furthest part that a person can see. So it is a right triangle, so I can apply my Pythagorean theorem. So first I know in part of the building was dealing with feet, but the radius of the Earth was dealing with miles, so I have to be able to go back and forth between the two of them. So I need to get everything in the same figure, and we're going to live in miles for this one. So I've got my d squared, that's the side that I don't know how far we can see, plus my other leg, the radius of the Earth squared, equals the entire length of that other radius, right? So I've got the radius of the Earth plus the height of the building. So that gives me that third side of my triangle. So I square that. So now I can just use my calculator and simplify and solve for d. So d is approximately 47.17 miles. And remember, we always need to include our units. So again, just looking at that figure. Okay, so now here are some general geometry formulas. We're going to move pretty quickly through these ones. So the first thing we definitely need to know is dealing with rectangles. I need to know the area and the perimeter, how to find those. With triangles, definitely be able to find the area of a triangle. Some circle things, we have to find the area, which is pi r squared, and my circumference. Make sure you note that the circumference we can either deal with the radius or the diameter. So now some three-dimensional figures, right? So I can have this shape. To find the volume, I multiply all my sides together. To find the surface area of a three-dimensional shape, I find the areas of all the different sides and I add them together. So now this is actually a sphere, not just a circle, but an actual sphere. So to find the volume, I'm going to use this formula, 4/3 pi r cubed, and the surface area is 4 pi r squared. One thing to note is area always deals with an exponent of 2, and volume always deals with an exponent of 3. Okay, so now I've got a cylinder, and again, here are my formulas. Here, you notice I said volume always deals with an exponent of 2, but when I multiply, I have an R and an R and an H, so that gives me 3 different dimensions. So that's what I'm looking at here. So now I'm going to go and use some of these. So a Christmas tree ornament is in the shape of a semicircle on top of a triangle. How many square centimeters? So I know because it's square centimeters, I'm dealing with area of copper is required to make the ornament if the height of the triangle is 6 centimeters and the base is 4 centimeters. So first thing we always do is to draw a picture. So here's the picture. So the base of my triangle was 4 and the height of my triangle was 6. So now I can go ahead and use the formulas that I know. And I know I'm dealing with area, so I have to find the area of the triangle and I have to find the area of this semicircle. So, and then I can add them together. So the area of my triangle is 1/2 base times height. I know that I'm only looking at half of the circle, so I can find half of the area of my entire circle and add those together. So approximately 18.28 centimeters squared of copper is needed for this. So now we're going to look at congruent and similar triangles. So congruent triangles are exactly the same, and I know they're exactly the same if my angles have the same measurement and the sides have the same exact length. So let's look at these. So here you see I have my angles are exactly the same. If these are going to be congruent triangles, I know that my corresponding sides, so B and E, would have to be exactly the same, and D and A would have to be the same, and C and F would have to be the same. If those three aren't all the same, then I know these triangles are not congruent. So to determine if triangles are congruent, I can use my angle side angle case, and those are kind of shown down here, right? So I see I have angles that are the same, the sides that are the same, and then the next angle. And when I'm looking at these, I always start at one corner and kind of work my way around in a circle to know I have the right order. So the second case would be my side, side, side. So if I see that all 3 sides are exactly the same, then I know that those are congruent triangles. And the third case would be side, angle, side. So the side, angle, side. And if that is the case, then I also know that those triangles are congruent. Okay. So now similar triangles. So triangles are similar if the angles are equal and the lengths are in proportion. And I want to look at all of the different lengths to make sure that they're all in the same proportion. So here is kind of a picture, an example. So you see how my angles are all exactly the same. However, if I take A and I multiply it by 2, and B and multiply it by 2, and C and multiply it by 2, and get these side lengths, then I know I have similar triangles. So there are a couple of ways I can determine if we have similar triangles. The first one is angle, angle. If I know 2 angles of my triangle, which would in fact also tell me the third angle, because I know all angles in a triangle add or sum to 180. If I know 2 angles in my triangle, then I know that they are similar triangles. I can also have side, side, side. But here you notice I do not have the same lengths, but I notice that I can multiply each side by 3 to get this larger triangle. So since I multiply by the same thing each time, that is a similar triangle. And then I can also have a side, angle, side, where my 2 sides are in proportion and my angle is exactly the same. Okay, so we're going to use these similar triangles. So given that these are similar, find the missing side length and the angles. Well, if they are similar, which we're told they are similar, I know that my angles are going to be corresponding. So this would be my 90, my 60, and my 30. Then I can see that I have a side length here and a side length here. And the thing that I'm looking for is right here, but I have the corresponding there. So I can go ahead and set up my ratio. So little leg over little leg equals big piece over big piece. From here, I can go ahead and cross multiply since I have two ratios that are equal. So I end up with 30 equals 3x. To get x by itself, I divide by 3. So x equals 10. So 10 would be this missing piece right here. And that's just shown exactly what we were just doing. So now let's look back at our learning targets, make sure we met everything for this section. First, we used the Pythagorean theorem and its converse. Second, we looked at some general geometry formulas. Make sure you have these all written down if you don't just have them in your brain already. And then thirdly, we looked at congruent and similar triangles and what makes those two things different. So now go ahead and work on your practice problems for this section.